Most of what you think keeps an engine alive is wrong. You are buying the wrong fluids, chasing the wrong specs, and rebuilding parts that were never the problem. Meanwhile, there is a single category of engine modification that added hundreds of thousands of miles to working trucks and daily drivers for over a decade. Shops made fortunes doing it. Owners swore by it. Diesel guys called it the smartest thing you could do to protect your investment. And then the federal government made it a crime. Not a fine, not a slap on the wrist, a prosecutable offense with six-figure penalties. The modification still works. The engineering still checks out. But if you do it today, you could lose your shop, your truck, and your freedom. This is the full story of what it was, why it worked, and what it means for anyone who still wants an engine that refuses to quit. To understand why this modification even exists, you have to understand what happened to diesel engines starting around 2007. Before that year, a diesel truck was about as simple as a combustion engine could get. You had a block, a head, a fuel system, and a turbo. That was basically it. Cummins, Duramax, Power Stroke, they all followed the same basic formula. Fuel goes in, combustion happens, exhaust goes out. There were no complicated aftertreatment systems, no computer-controlled regeneration cycles, no tanks of chemical fluid bolted to the frame. A well-maintained diesel from that era could break 400,000 miles without a major overhaul, and plenty of them did. Some crossed 600,000. A few legendary ones hit 1 million. The engines were not fancy. They were just clean in their design. Every part had a job and nothing was fighting against itself. Then emissions regulations changed everything. The Environmental Protection Agency started tightening standards on nitrogen oxide and particulate matter coming out of diesel exhaust. The targets were aggressive, and automakers had to figure out how to meet them fast. What they came up with was a layered system of emissions equipment. Three big ones were the exhaust gas recirculation valve, the diesel particulate filter, and the selective catalytic reduction system that uses diesel exhaust fluid. Each one had a specific job. The EGR valve was supposed to reduce combustion temperatures by feeding a portion of exhaust gas back into the intake. The DPF was supposed to catch soot particles before they left the tailpipe, and the SCR system sprayed a urea-based fluid into the exhaust stream. On paper, it was brilliant. In practice, it started killing engines. The EGR system was the first domino. When you take hot, dirty exhaust gas and push it back through the intake manifold, you are coating the inside of your engine's breathing system with carbon and soot. Over time, the intake ports clog. The EGR cooler, which is supposed to lower the temperature of that recirculated gas, cracks from thermal stress. Coolant leaks into places it should never be. On the 6-liter Power Stroke, EGR cooler failure became so common that it practically defined the truck's reputation. Ford sold thousands of Super Duties that ended up in shop after shop with the same failure. The fix was expensive. The root cause was the system itself. The engine did not need that exhaust gas back in its intake. It was forced there by regulation, and the engine paid the price. Then the DPF started showing its problems. The diesel particulate filter traps soot. That is its entire purpose, but soot builds up and the filter has to be cleaned. The way the system handles this is through a process called regeneration. The truck's computer injects extra fuel into the exhaust stream to raise the temperature inside the DPF high enough to burn off the trapped soot. This can happen while you are driving, and you might not even notice. But if the regeneration does not complete, because you shut the truck off too soon, or you are doing short trips, or the sensor is not reading correctly, the soot keeps building. Eventually the filter clogs. When it clogs, the truck goes into limp mode, power drops, warning lights flood the dash, and the repair bill to replace or clean a DPF can run anywhere from $2,000 to $5,000. On trucks that work for a living, hauling loads and running job sites, DPF issues became one of the most common and most expensive failures owners dealt with, not because the engine was weak, because the filter was choking it. The DEF system added another layer. Diesel exhaust fluid is a mixture of urea and deionized water that gets sprayed into the exhaust. It works with the SCR catalyst to reduce nitrogen oxide output. The concept is sound, but the execution introduced a whole new set of failure points. DEF injectors clog. DEF fluid crystallizes in cold weather. The DEF tank heater fails. The quality sensor throws false codes. And here is the part that made truck owners furious. If the DEF system detects a fault, even a minor one, it can derate the engine. That means the truck limits itself to 5 miles per hour, not highway speed, not reduced power, 5 miles per hour. On a truck that might be carrying a full load on a freeway on-ramp. It was a safety nightmare for some owners, and it was all triggered by a system that had nothing to do with the engine's ability to run. If you are watching this and you work on trucks, or you have owned a diesel from 2007 or later, none of this is news. You lived it. You watched good engines get strangled by the equipment that was bolted onto them. And that is exactly why the delete modification became so popular, because it solved every single one of those problems in one shot. A full delete on a Postman S 2007 diesel meant removing the EGR system, removing the DPF, removing the DEF system, and flashing the engine's computer with a custom tune that told it none of that equipment was there anymore. Once it was done, the truck ran like a Premonus 2007 diesel, clean intake air, no soot trap, no chemical injection, no derate risks. The turbo spooled faster because the exhaust was not being choked. Fuel economy improved, sometimes by 2 or 3 miles per gallon, because the engine was not burning extra fuel for regeneration cycles. Exhaust gas temperatures dropped because the system was not constantly fighting restriction. And the engine's oil stayed cleaner, longer, because soot was not being recycled through the intake and contaminating the crankcase. The results were not subtle. Owners who deleted their trucks and kept up with basic maintenance were reporting 300,000, 400,000, even 500,000 miles without major engine work. That is not internet exaggeration. That is real-world data from fleet operators who tracked every mile and every dollar. A deleted 6.7 Cummins in a Ram, with regular oil changes and clean fuel, became one of the most reliable powertrains on the road. A deleted Duramax LML or LBZ was the same story. Even the 6.7 Power Stroke, which had a rough reputation in stock form, became a different animal once the emissions equipment was removed and a proper tune was loaded. The modification did not add horsepower. For the sake of bragging rights, it removed the things that were actively damaging the engine. That is why it worked so well. It was not an upgrade. It was a restoration of the original engineering intent. For a while, the delete industry was booming. Shops all over the country offered the service. Tuning companies sold plug-and-play kits. You could order a delete kit online, have it shipped to your door, and either install it yourself or take it to a local diesel shop. Prices ranged from $1,500 to $3,000, depending on the truck and the level of tune. For an owner who was staring at a $5,000 DPF replacement or a $3,000 EGR cooler repair, the math was simple. Spend less money, get a truck that runs better, lasts longer, and costs less to maintain. It was not even a hard decision for most people, and that is where the federal government stepped in. The Clean Air Act makes it illegal to tamper with, remove, or disable any emissions control device on a motor vehicle. That law has been on the books for decades. For a long time, enforcement was almost non-existent when it came to individual trucks and small shops. The EPA focused its attention on manufacturers and large-scale industrial polluters. The guy running a diesel shop in a small town was not on anyone's radar. That changed around 2020. The EPA launched a formal crackdown on what it called the aftermarket defeat device industry, and the numbers were staggering. If this kind of deep engineering breakdown is what you come to this channel for, take a second to subscribe. This is a community built around understanding what actually makes machines last, not hype, not trends, just the mechanical truth. Hit subscribe so you do not miss what comes next. The EPA estimated that over 500,000 diesel trucks had been illegally deleted. They calculated that those trucks collectively added more than 570,000 tons of excess nitrogen oxide and 5,000 tons of particulate matter into the atmosphere. Those numbers got Congress's attention, and the penalties that followed were severe. The EPA started going after tuning companies first. Some of the biggest names in the diesel performance world were hit with multi-million-dollar fines. One company in Florida was fined over $9 million. Another in the Midwest was hit for over $3 million. Several shop owners faced criminal charges, not just civil penalties. Employees were prosecuted. Businesses were shut down. The message was clear. The delete was no longer something anyone could look the other way on. By 2023 and into 2024, the enforcement expanded to shops of all sizes. It was not just the big tuning companies anymore. Local diesel mechanics who offered delete services were getting letters, audits, and in some cases, visits from federal investigators. Some states added their own penalties on top of the federal ones. In California, a deleted truck cannot pass smog inspection, and driving one on public roads carries its own fines. In states with annual inspections, a missing DPF is an automatic failure. For truck owners, the consequences were just as real. A deleted truck cannot legally be sold in many states without the emissions equipment being reinstalled. That reinstallation can cost more than the original delete. Some owners found themselves stuck with trucks they could not register, could not sell, and could not afford to bring back to stock. The irony is thick enough to taste. The modification that made diesel engines last the longest is the one that became the most aggressively prosecuted. And the emissions equipment that causes the most engine failures is the equipment the law says you must keep. Now here is where the story gets even more interesting, because this is not the first time something like this has happened. If you go back to the middle of the 20th century, there was another substance that made engines run longer, smoother, and with far fewer problems. It was called tetrethyl lead, and it was added to gasoline starting in the 1920s. Lead in fuel did two critical things. It raised the octane rating, which prevented engine knock, and it coated the valve seats with a thin layer of soft metal that cushioned the valves every time they closed. That cushioning effect dramatically reduced valve seat recession, which is when the valve slowly hammers its way deeper into the head with every cycle. Engines running on leaded fuel had valve seats that lasted for the life of the engine. When lead was removed from gasoline in the 1970s and fully phased out by the mid-1990s, older engines started chewing through their valve seats at an alarming rate. Heads that had run fine for 200,000 miles on leaded fuel were failing at 50,000 on unleaded. The automotive industry had to adapt. Manufacturers started using hardened valve seat inserts made from powdered metal alloys, pressed or machined into the cylinder head. These inserts could handle the impact of the valve without the protective lead coating. It was a permanent engineering solution to the problem created by removing lead from fuel. And it worked. Modern engines do not need lead because the metallurgy has caught up, but the transition was rough. Thousands of classic cars and trucks from the 1950s and 1960s suffered premature valve failures because their owners did not know the fuel had changed, and the heads were not designed for it. Some people ran lead substitute additives. Some had their heads machined for hardened inserts. Some just kept driving until the valves burned and then dealt with it. The parallel to the diesel delete situation is almost perfect. A substance or a modification that protected the engine was removed for environmental reasons. Removal caused mechanical harm. The industry eventually found engineering workarounds, but during the transition, a lot of engines suffered unnecessarily. There is a lesson in that pattern, and it matters for anyone who works on engines today. The engineering that makes an engine last is not always the engineering that the law allows. That does not mean you break the law. It means you understand the forces at play, so you can make smarter decisions within the boundaries you have. So what can you actually do right now, legally, to get the most life out of a modern diesel or a classic engine that was designed around systems or fuels that no longer exist? The first thing, and this is the one most people skip, is understanding your oil. Not just the brand, not just the weight, the actual additive package. Modern diesel oil has to meet specific API ratings, and those ratings have changed over time. The current top-tier rating for diesel oil is CK-4, and it was designed specifically for engines running with DPF and SCR systems. CK-4 oils are formulated with lower ash content because high ash levels can clog the DPF faster. If you are running a stock emissions-equipped diesel, you need to be using CK-4 oil, and you need to be changing it on time, every time. Soot loading in diesel oil is real, and it thickens the oil over time, reducing its ability to protect bearings and rings. A $500 a year oil change habit can save you a $10,000 engine rebuild. That is not a cliche. That is the math. For owners of older engines, especially flathead and early overhead valve designs, from the pre-unleaded era, the hardened valve seat insert is still the gold standard. If you are restoring a classic, straight six or a big block from the 1950s or early 1960s, have the machine shop check the valve seats. If they are original soft seats, get them cut for hardened inserts. The cost is minimal compared to the protection it provides, and do not rely on lead substitute additives as a long-term solution. They work in a pinch, but they are not a replacement for proper metallurgy. If you are running a diesel truck and you want to protect the EGR system without removing it, the best legal approach is to keep the EGR cooler clean and monitor it for early signs of failure. Some aftermarket companies make EGR cooler upgrades that are emissions legal, meaning they do not remove the system but replace the factory cooler with a more robust design. These are worth every dollar on engines that are known for cooler failure, like the 6-power stroke. For the DPF, the single best thing you can do is let regeneration cycles complete. If your truck starts a regen, do not shut it off. Drive it until the cycle finishes. Short trips and constant stop and start driving are the worst thing for a DPF-equipped diesel. If your truck is mostly used for short trips, consider taking it on a highway run once a week to let the system clean itself. And if the DPF does clog, look into professional cleaning services before you spend the money on a full replacement. A properly cleaned DPF can perform like new at a fraction of the replacement cost. On the DEF side, quality matters more than most people realize. DEF has a shelf life and it degrades in heat. Do not buy the cheapest jug off the shelf at a truck stop that has been sitting in the sun. Store your DEF in a cool place. Use it before the expiration date. And if your DEF system throws a code, do not ignore it. Minor DEF sensor issue that costs $200 to fix can turn into a full SCR catalyst replacement. That costs thousands if you let it go. If you are still watching, drop a comment and let us know what you are driving and what kind of mileage you have put on it. This channel exists because people who care about real engineering deserve a place to share what they know. Your experience under the hood matters here. There is another legal modification that is gaining traction and it deserves attention. Catch cans, an oil catch can installs between the crankcase ventilation system and the intake, and its job is to capture oil vapor and condensation before it reaches the intake manifold. On a turbocharged diesel with an EGR system, the combination of oil vapor from the crankcase and soot from the EGR creates a thick tar-like sludge that coats the intake ports. A catch can does not remove the EGR. It does not chain the emissions output, but it keeps the intake significantly cleaner, which means the engine breathes better and the EGR system does not have to fight through as much buildup. It is a $50 to $200 part that can add years of life to your intake system, and it is completely legal. Fuel quality is another factor that gets overlooked. Diesel fuel varies more than most people think. Low-quality fuel with high sulfur content or water contamination accelerates wear on injectors, pumps, and the entire fuel system. Running a quality fuel additive that includes a cetane booster and a lubricity agent can make a measurable difference in how smoothly the engine runs and how long the fuel system components last. This is not snake oil. The diesel fuel specification allows for a wide range of quality, and most pump fuel sits at the low end of that range. A good additive brings it up to where it should be. For the classic car side of this conversation, there is a modification that mirrors the diesel delete in spirit, even though it is on the opposite end of the technology spectrum. Electronic ignition conversions. Older cars with points-based ignition systems require constant adjustment. The points where the timing drifts and the spark weakens over time. An electronic ignition module, like a Pertronix or a similar unit, replaces the points with a solid-state trigger that never wears. It fits inside the original distributor, so the engine looks completely stock from the outside. But the spark is stronger, the timing is more consistent, and the maintenance drops to almost zero. It is one of the most cost-effective reliability upgrades you can do to a classic engine, and it is fully legal because it does not affect emissions. It just makes the ignition system work the way it should have from the beginning. The same philosophy applies to modern ignition coils, upgraded plug wires, and higher quality spark plugs on older engines. None of these change the emissions profile of the engine. They all improve combustion efficiency, which means the engine runs cleaner on its own, without needing external equipment to scrub the exhaust. Better combustion means less unburned fuel, less carbon buildup, and less stress on every component downstream. There is a reason the best mechanics in the world focus on combustion quality before anything else. If the burn is clean, everything else falls in line. The oil stays cleaner, the rings last longer, the valves seat properly. The catalytic converter, or DPF, has less work to do. It is the foundation of engine longevity, and it has been true since the first internal combustion engine fired. Now, here is the uncomfortable truth that ties this whole story together. The diesel delete worked because it removed obstacles to clean, efficient combustion. The emissions equipment, as necessary as it may be for air quality, introduces restriction, recirculation, and chemical processes that create mechanical stress. The delete eliminated that stress. The engines responded by lasting longer. That is not opinion. That is observable, repeatable mechanical reality. The question society had to answer was whether the environmental cost of those emissions was worth the mechanical cost to the engines. The government decided it was. You can agree or disagree with that decision, but the engineering does not care about politics. The engineering just tells you what happens when you add restriction to an exhaust path or soot to an intake manifold. What you do with that knowledge is up to you. If you are running a stock emissions-equipped truck, your job is to maintain those systems perfectly so they cause as little collateral damage as possible. If you are restoring a classic, your job is to understand what that engine was designed to run on and make sure the modern equivalents are in place. If you are building something from scratch, your job is to engineer combustion quality from the ground up, so the engine does not need external systems to compensate for a dirty burn. The modification that made cars run forever was not magic. It was not a secret formula. It was the removal of things that were hurting the engine. And while the law now says you cannot remove those things, the principle behind the modification still applies to every single decision you make in your garage. Every time you change the oil on schedule, you are removing contamination. Every time you install a catch can, you are removing soot from the intake path. Every time you upgrade to a hardened valve seat, you are removing a wear point. Every time you use quality fuel, You are removing the trash that accelerates injector failure. The delete was just the most dramatic version of a philosophy that every great mechanic already follows. Remove what hurts the engine, protect what helps it. Stop scrolling through listings, looking for a truck that someone else already deleted. That era is over, and the legal risk is not worth it. Instead, look for engines that were built right from the factory. Preminous 2007 diesels with mechanical simplicity. Classic straight sixes with hardened seats and electronic ignition upgrades. Late-model trucks with meticulous maintenance records showing every filter change, every regen cycle completed, every DEF system service done on time. The best engines are not the ones that had the most work done to them. They are the ones that had the right work done, at the right time, by someone who understood what the engine actually needed. That is the real secret, not a modification, not a kit you order online. Just knowledge, the kind that comes from decades of turning wrenches and paying attention to what breaks and why. You now have a piece of that knowledge. Use it the next time you open a hood, the next time you look at a listing, the next time someone tells you their truck needs a delete to run right. You will know the full story. You will know why it worked. You will know why it is gone. And you will know exactly what to do instead. One smart decision in your garage is worth more than 1,000 hours scrolling through forums. Go make that decision.